Hey, morning. Mr. Lesham here once again. And now this is kind of we're basically taking all the tools that we learned about the first derivative, the second derivative, stationary points, point inflection, everything. And all these tools are going to allow us, hopefully, to be able to draw cubic function, to actually sketch them. Okay? So a cubic function, I've spoken a lot about it already. Is generally looks like this. F of x equal a times x cubed. A is some kind of parameter. B x squared plus cx plus d. So that's a cubic function. Okay. We've learned a lot about quadratic function. Now we have cubic function. And so our aim is going. If I give you a, b, c, and d, I give you a bunch of numbers. By the end of this investigation we're doing, we'll be able to plot it. Okay. Before we do an example, I need to draw all the possible shapes that we're going to have. Okay? So the shapes that we're going to have are based on maybe two things. First of all, how many stationary points we have. So we can have two stationary points, or we can have one stationary point, okay? Which is also a point of inflection, if you think about it, or no stationary point. Okay? There is no place here in these two graphs where the gradient is 0. So these are the three options. I say three because there's three options, but each one of them have two options really. Either this thing kind of goes up when I'm saying kind of going up because it does go up and then down a bit and then up again. Up all the time, up. Or does it go down, meaning going down, maybe up a bit, but then down again. Down, down. Okay? Now, what determines if it goes up or down is your A. And I think if I ask you this question now, you'll be able to guess. If I've got a positive A, if A is positive, which one do you think of these graphs is going to represent? Those one, the one that goes up, or those one, the one that goes down? A positive A, what do you reckon? It's going to go up. You're absolutely right. If the A is positive, then generally this function is going up. Again, I'm saying generally because it goes up, but here there's a little area where it goes down, right? Like in the middle, okay? But generally speaking, it goes up. And that means when A is negative, okay, it goes down. Now to try and explain it, I'll give it a go. If you get it, great. If you don't get it, don't worry. You just need to remember it, and it kind of makes sense. If I want to know what is the value of the function, f of x when x is bless you. Okay. If I want to know what the value of the function f of x when x is very large, like x equal 1,000,000. Let's imagine x equal 1,000,000. Now, which one of these terms, ax cubed, bx squared, cxd, which one do you think is going to be the most dominant, the most big, the biggest when x is very large, like x is equal 1,000,000? It's going to be the first, the second, the third, or the fourth? It's the first. It's the first. Why is it going to be the first? Because x cubed, think, 1,000,000 cubed is way more than d. Or it's way more than just some number time 1,000,000. 1,000,000 cubed is a huge number. So what I'm trying to say, and hopefully kind of convince you a bit, is that when I'm looking at very large x, this is the dominant term. The rest we can almost neglect them. This is so much bigger. So when x is positive 1,000,000, if the A is positive, then this is going to be positive. But if x is negative 1,000,000, if I'm looking to the far left side, if x is negative 1,000,000, then this is going to, if A is, So if x is a negative 1,000,000, negative 1,000,000 power 3 is a very large negative number. So it's going to be a negative number, and that means this graph goes down this side. But if A is negative, then everything flips up. When x is positive, okay, that's going to be a positive 1,000,000, but A is negative, that's going to flip it to go down. Okay? If you didn't get it, don't worry about it. What you just need to remember, what you kind of guess, it's intuitive. Positive A, this graph is generally going up. Negative A, the graph is going down. I'll just pause for question. So before we dive into our first and only example of today, what do we actually need to do to sketch a graph? Once I give you the A, B, C, and D, a specific function, first of all, we find the x-intercept. Okay? That's basically where y is equal to 0. Then we find the y-intercept. That's where the x is equal to 0. I would actually do it the other way around because y-intercepts are much easier. How do I find the y-intercept? X equals 0. Then I find the stationary points. These are these stationary points. Or maybe there is no stationary point. Or maybe there's just one. Okay? And then finally I find the point of inflection. Once I have all these points, then I'm just going to complete the line. Okay? Let's do it. Right. So guys, here's our first function. X cubed minus 6x squared. Now, unfortunately, I couldn't keep the other shapes. Is it going to be a shape that kind of goes up or goes down? It's going to go up because the A is positive, right? But we don't know if it's actually going to be like this, or maybe with 2 stationary points, on 1 stationary point, or 0 stationary point. So we're going to find out. Now, I'm going to go according to what they told us here. We don't have to go in that order. We could actually straight away, first of all, find the stationary point. It doesn't matter. Okay? Do you know what? I'm going to go with the way they do it in the textbook. We'll just go with that. So you can check. It's in page 109. So rather than looking for the x and the y-intercept, first of all, let's find the stationary point. How do I find stationary point? Okay, this is all stuff we've done. Find the derivative. Okay, so we're going to have 3x squared minus 12x. Okay, alright, what about the derivative? How does that help us to find the stationary point? 2 factorize? No.
You can find the second derivative.
I make it equal to 0, right? Because stationary point, remember, stationary point, the first derivative is 0. Maybe I'll write it down in red. Okay? Stationary point. I can say like equal, first derivative equals 0. Okay? So we're going to find, we're going to basically say 3x squared minus 12x equal to 0. That's easy. I divide by 3. X squared minus 4x equals 0. Okay? Now I'll factorize, Eugene. Okay? So I've got x equals 0 or x equal 4. Okay? Now before I find out the nature of these stationary points, is the maximum, is the minimum, okay? I must, in fact I won't even need to do it. Let's find out the y. Okay, let's find out the y. How would I find the y? Well, I sub it, where do I sub? Always. If I want to know the y, I sub in the original, okay? So f of 0 is going to be 0 cubed minus 6 times 0 squared, which is 0. And f of 4 is going to be 4 cubed, oh my goodness, times 6, 4 squared. Okay, 4 cubed, 64 I think? Yes. 4 squared, so it's 64 minus 6 times 16. 6 times 16 is, need your help guys? So 64 times 6 times 16, how much?
Negative 96.
Negative 96.
Yes.
So this is 96.
Yeah.
Yeah, check me?
Yeah.
I gotta get it right. Yeah, we can actually, I can check them. I got minus 32 altogether. That makes sense?
Yeah.
Yes, okay. So the 2 points that I've got are 0, 0. That's 1 point, right? 0, 0. And the other one is 0 minus 32.
No, there's a false.
Oh, that's a false. Of course, I can't have, otherwise it's not going to be a function. So, by the way, already now, I like to plot, so here I'm going to plot eventually the graph. So I'm going to have a plot here, and I'm going to have 4 minus 32, which is, let's say, here. Now, I know that these two are, they are 2 stationary points. Now, in theory, I need to decide are they maximum or minimum, right? How would I decide if they're maximum or minimum? How do I find?
Bigger, smaller than 0.
What is bigger or smaller than 0? What is bigger? So you're right, something is bigger or smaller than 0 for the
Second derivative.
the second derivative. So I need to find out the second derivative. The only thing is I don't even need to do it. Why don't I need to do it? Because I know out of these shapes, I know that the shape we spoke, that's why it's good to look at the shape. The shape is going to be like that, right? It's going to be a graph that's going up, right? Yes?
Yes.
Now we said we have a graph that's going up, so it's not like this. It's either like that, or like that, or like that. But now I found two stationary points. Okay? If I found two stationary points, which one is it going to be? The first, the second, or the third? The first has two stationary points. But now because I know this graph is going up, what is this going to be? A maximum or a minimum?
That's going to be.
If this is the shape, what is that? Going to be a maximum or minimum?
Minimum.
Right.
Which one comes first? A maximum, right? So that's going to be a maximum, and that's going to be a minimum. Can you see? Because we agreed that this is, because the A is positive, we know it's going up. We can't have a minimum and then a maximum. It has to be a maximum and then a minimum, yeah? So what I personally do at this point, I just draw a little kind of thingy like this, maybe in pencil if you have, just to remind you this is a maximum, this is a minimum. Now, if you don't understand this trick, don't worry about it. You can just find out the second derivative. Okay? So the second derivative is going to be 6x minus 12, right? Now we just want to confirm, okay? If I find the second derivative when x is equal to 0, it's going to be 6 times 0 minus 12, which is minus 12, which is smaller than 0. So I know that this is a maximum. 0 is a maximum. Yes, I know it's a maximum. Okay? In case you didn't really understand what I was saying, you can go the long way. It's not a big deal. And then I want to find out the second derivative of x equal 4. Okay? So I'm going to put 6 times 4 minus 12, which is 36 minus 4 is 24, I think.
No, it's 12.
Is it 12?
6 times 4 is
24, you're right. So it's 12. But in any case, it's positive, meaning it's a minimum, right? So that's a maximum, and that's a minimum, as it should be. I know it should have been. Okay, so I'm putting this thing in brackets. Okay, you didn't really have to do it, but you can also do it. I'll just pause for question. The next step, I'm running out of space. Okay, let me just clear out some space. So we've done the stationary point. And in fact, guys, I already managed to find, I'm claiming that I found the y-intercept. Because look, I found where it crosses the y. You see, that's why maybe it was a good thing to start with a stationary point, because I already know where it crosses the y. There's no point in subbing x equals 0 now. I know it's going through 0, 0. Okay? So now I know there will be some kind of, you know, if I extend this, I know there's going to be an x-intercept here. Okay? Will there be another x-intercept? Well, there is one at 0, 0. Okay? So I'm going to have, so the graph is going to look like this. Okay? Something like this. Okay? So I'm going to write down 0, 0. Okay? I've got the turning point here, the stationary point. I've got this stationary point. I don't have that one. I will still need to find it. But I still need the point of inflection. Now at this point, before we actually calculate it, we will calculate. I want to see if somebody can guess what is the x value of the point of inflection. I just want to put it there. This is 0.
I would say 8.
Okay, this is 0, 0. This is 4 minus 32. What will be the x value of the point of inflection? 8.
Oh, you can what?
Okay, this is 0, 0. The x here is 0. The x is 4. Where would be the point of inflection?
I don't even know what that means. 2? Oh, at 2, yeah. 2 then.
Okay, right? I heard the answer, but let's find. Okay, I'm hearing 2. Okay, maybe. Okay, so okay, some of you are mentioning. Yeah, no, that will be later. That will be later. So we're looking for the point of inflection, and Simon and JD are saying 2. Okay, why do you think it's going to be 2? Yes, like, well, why did you guess 2?
It's in the middle.
It's in the middle between the stationary point. It turns out you're absolutely right. Okay, the stationary point is always going to be, if you have two stationary points, okay, if you have two stationary points, you don't always have two stationary points, but if you do have two stationary points, in a cubic function, the point inflection is always going to be halfway between. But in non-cubic function, it's not the case. Luckily for us, we're always going to just deal with cubic function. But anyway, we're going to continue to find out the point inflection just to prove this, because I'm not expecting you to remember that. How do I find out what is the x of a point inflection? What do I have to do?
Make it equal to 0.
What is equal to 0?
The
The second derivative must be equal to 0. So I'm going to make that equal to 0. 6x equal 12, x equal 2. Well done, Jamie and Simon. Okay? So I know this is 2. Okay? So you can try and remember it. It's a good trick. It's going to save you some time. It's going to maybe allow you to check your answers, that the point inflection is always going to be between the two stationary points. How do I find the y? Sub in what?
0.
So sub 2 where?
The ridge.
In the original one, okay? So y is going to be equal to 2 cubed minus 6 times 2 squared. See, that's where things wrong. People will put 2 maybe in the first derivative, the second derivative. Always to find the y, you sub it in the original function, and I'm getting 8 minus 24, which is, what is 8 minus 24? Minus 16, they say. Does that make sense? Okay. So minus 16, which is also halfway through, which kind of makes sense. You're absolutely right. Okay? So what do we have so far? We have two stationary points. We have point of inflection. They won't tell you in the paper, in the test, they'll ask you to sketch it. They won't tell you plot the stationary point, plot the intercept, plot the point of inflection. You need to do it. You need to know to do it. Okay? So we've got all that. We're still waiting for the x-intercept, right? Let me just pause here for a second. So how do we find the last x-intercept? I'm going to just get rid of this. How do we find, guys are listening, how do we find x-intercept?
Make y equal 0.
Y equals 0 in the original function, right? So we're going to say x cubed minus 6x squared equal to 0. Okay, how do we solve such a thing? It's been a while since we've done it. Take
common factor,
which is
x squared.
And then we're going to have x minus 6 equal to 0. So we have two solutions, isn't it?
Yeah.
X equals 0, which should be, because that is an intercept.
And
And x
x equals 0.
equals 6, which is our missing. How would our missing intercept? How do I know what the y is?
It's on the x-axis,
So y is
0.
0. Obviously, I don't need to sub anything. Okay, I'll pause here, guys. I'll pause. Okay? Videos, enjoy your matric dance. Bye-bye.